Good day, viewers. You are welcome to Tindanius Maths and Science tutorials. We are going to consider increasing and decreasing functions as part of calculus. You are welcome once again to the channel. So let me consider increasing function. What do we mean when we say a function is increasing? So let me draw my rectangular coordinate system. This way I have my x-axis or the abscissa, I have my y-axis or the ordinates. So let me consider any graph at all. But just to make sure that the graph is increasing. Alright? So if this is, so let's say I have a graph this way, let's say start from here, then let's say gradually it has increased to, let's say, a point this way. So this point refers to my corresponding y-axis, this side, and this is my corresponding x-axis. So this is my graph for increasing function. Let's trace one end of the graph to the y-axis and the other end to what? The y-axis. So because it starts from here and it keeps increasing this way, so I will say my f here will be my f of x1. Why not x2? x1 because it will start from this point, then gradually it takes this form, then to the final point of say f of what? Of x2. This way. Now, since I have the corresponding y values, I also have to get to the corresponding what? X value. So if I'm able to trace this point to touch the x-axis this way, and I have my y value here, I just trace it this way to touch the x-axis. So I have here x1, I have here x2 in that regard. Alright, for a function to increase, then what it means is this: you realize that x1 is less than or equal to x2. We claim x1 is less than x2. That is, so I'll have x1 is less than, or let's say less than or equal to x2 for this case. Also, when considering the function this way, it started from here. Then it was able to take this part to this end. So what can we deduce? What we can deduce is this. So you see that f of x1 here is also less than or equal to f of x2. So x1 is less than x2 from this side. You can see clearly. Because it started from this point, so we assume this is our initial or starting point, and of course, and this is our terminal point. So this is also what's greater than this. So we have a function in this form where, so what it means is that, let me come here. So if x1 is less than or equal to x2, this implies that from the graph, f of the x1 is also less than or equal to f of what? Of the x2. When you have a function this way, we say that the function is increasing. So this is what we mean by what? By increasing function. So if x1 is less than or equal to x2, then what it implies is that f of x1 is also less than or equal to f of x2. Alright? So let's consider decreasing function. Alright, so let us consider decreasing function. Decreasing for decreasing function, again, drawing our rectangular coordinate system. We have our x-axis, we have our y-axis. So let's say we have a graph here, then let's assume as the graph goes this way, it's what? It's reducing. We get that way, decreasing. So let's assume this is our starting point, okay? Our initial point. Let's say, let me call this f of x1, and let's say it ended here. This is our last point. So if I trace this onto the y-axis, I have f of x2. Alright, so let me look out for the corresponding x values from here. So if I trace this to this side, and also trace this to this side, I'll call this what? My x1, I'll call this what? My x2. So again, from the graph, x1 is less than or equal to x2. So I have x1 is less than or equal to what? X2. Now let me consider the vertical axis. Here, it started from here and it ended over here. See, when we're considering the increasing function, realize that f of x1 was greater, but here, because f of x1 it started from here, and as it takes this trajectory, it reduces. Is that also? So clearly you can see that my f of x1 is greater than or equal to what? My f of what? Of x2. So we have a situation where x1 is greater than or is less than or equal to x2. Then it implies that f of my x1 is greater than or equal to my f of x2. In a situation like this, we say that this is what? The function is decreasing. So this is the main difference between what? Increasing function and what? And decreasing what? Function. You don't have to memorize. You just have to see how you can draw the graph and pick it up from there. Viewers, if a function of say y is differentiable, alright, so for all values of x belonging to the set of a, comma b, alright, when you are given a function and you differentiate that function, we get what? We get dy over what? Over dx. So we have a situation where dy dx is greater than 0. We say that the function is increasing. So the function is increasing. Also, when dy over dx is less than 0, we say what? The function is decreasing. So in a nutshell, given that f of x is a function, when you differentiate f of x, you get what? F prime of x. So if f prime of x is greater than 0, you say that this is what? This function is what? Is increasing. Also, if you differentiate the function f of x and is less than 0, we will say that what? The function is decreasing. Viewers, this is how the concept goes. So let's see how we can appreciate questions under this. Okay, so viewers, we have questions on the board. Show that y equals x to the power 3 minus 3x to the power 2 plus 3x plus 1 increases. You now understand the word increases over here for all real values of x. Alright, we said that for a function to increase, that means, so if I have a function of say y equals x cubed minus 3x squared plus 3x plus 1. If I find the derivative of this, I'll have y over the x equals, using the power rule. Viewers, if this is your first time, kindly visit our previous lectures where we've dealt with calculus into details, I mean the introduction, where we made mention of the product rule, the chain rule, and the quotient rule. And we even talk about what? Differentiating polynomial functions using the power rule. So here we're going to employ the power rule. So if I differentiate this, I'll have 3x, then you subtract 1 from the exponent, I'll have 2. Then minus 3 to 6, then x, take 1 from the exponent, then plus, if I differentiate 3x, I'll have what? 3. If I differentiate a constant, I'll get what? 0. So, for a function from the question, you can see that the function is increasing. So what do we mean by say like a function is increasing? A function is increasing when the y over the x is what? Is greater than what? 0. So therefore, we have to equate this what? This expression in this way, such that this expression will be greater than 0. So this is my dy dx. And where is my dy dx? My dy dx is what? Is the whole of this. So I have my 3x squared minus 6x plus 3. Then we said what? Greater than what? Greater than 0. So let's apply. Okay, we can divide through by the common factor, which is what? 3. So 3 divides 3. So I have s squared minus 3 divides 2. So 2x plus 1 is greater than what? 0. Viewers, this and that, they are the same. Alright, I only divided this through by a common factor just to simplify my calculations. Okay. So we have to just factorize this. So the coefficient of this is 1, right? So I have 1 here. The factors of 1. So we have negative 1 and negative 1. Get that. So when I factorize this, I'll have x squared minus x plus 1 is greater than what? 0. Is that also? Then we have x is common, so we have x minus 1, then we have 1 here, then we have x minus 1 is greater than what? 0. So I'll have x minus 1 in one bracket, then I have x minus 1 is greater than what? 0. Now class, the question says, show that the given function increases for all real values of x. When you expand this, you get back to this. You get back to this or that. So viewers, you can end here. Why am I saying you can end here? You can end here because they are saying for all real values of x. If I put negative over here, x is equal to negative over here, and x is equal to negative. the value and so let's test for our values. I have x minus 1 and I have x minus 1 greater than 0. So if x is equal to, let's say, negative 1. So I have negative 1, multiplying negative 1, negative 1. So let's compute this to see whether it's greater than 0. So I have negative 2 times negative 2. I'll have positive 4, which is greater than 0. So whatever value, if you insert any real number in this set of inequality, it will always be greater than 0. It is in two folds. Either it will be greater than 0 or it will be greater than or equal to 0. So it's either greater than 0 or equal to what? 0. So because all real values, when substituted into this inequality, will be greater than 0. So therefore, we say that this function is increasing. So you can try any value, any possible value for x, when you put it inside the set of inequality, it will be greater than 0. So this has been confirmed. That's all. Let's work out for this. This time around, we are supposed to find the intervals. So let's see how this also goes. So find the intervals where the curve y equals this is decreasing. So I have to differentiate this first to get y is equal to, using the power rule. Here I'll get 3x squared over 3 plus, here I'll get 2x over 2 minus 2. This 3 appears here as the coefficient 3 over here, and this 2 also appears as the coefficient. And when you differentiate 2x, you are supposed to get 2. When you differentiate a constant, you get 0. So clearly 3 cancels 3, 2 cancels 2. So I have y over the x is equal to x squared plus x minus 2. Now because we have been told the function is decreasing, so for a decreasing function, y dx is supposed to be what? Less than 0. Is that also? So here will be x squared plus x minus 2. It's less than what? It's less than 0. So again, when I factorize this, so we have negative 2, then let's look at the factors. Negative 2 have 1 and negative 2. Then we have negative 1 and 2. So I think I'll opt for negative 1 and 2. Alright, so when I factorize this, I'm supposed to get x squared minus x plus 2x minus 2 is less than 0. So therefore, when I factorize this, the common this one is x. So I have x, then I have x minus 1 plus 2, then I have x minus 1. It's less than 0. So I can therefore say that x, let me rewrite it. So x this way. Okay, so since the brackets are common, I pick 1, x minus 1, then I will include the coefficient. X plus 2 is less than 0. Okay, this one, we have what we call quadratic inequality. Because we want to find for the interval, you have to graph this. So here, what is the meaning of this inequality is we have x minus 1. So if you have x minus 1, what it means is that your x is supposed to be positive 1. And when s plus 2, this is positive 2. It means that s is equal to negative 2. So that we can plot it. Okay. So if I have this way, let's say, so So x minus 1 is equal to 0. I'll get x is equal to 1, positive 1. So let me put my this is positive 1. If I have x plus 2 is equal to 0, so it means x. So if x plus 2 is equal to 0, so I have x is equal to negative 2. Alright? Okay, so which means my negative 2 will come here. Okay, so now because this is a quadratic inequality, so we need to draw for this so that we can write for the intervals. So when I draw my graph this way to pass through this and that this way, this is the region we are looking for, this region. And this region is less than 0. So if I want to write the intervals, I will say that negative 2 is less than x less than 1. So viewers, this is the interval. Also, this is a minimum graph. Why we say it's a minimum graph? Because this is a minimum graph. If you want to know this very fast, whenever the coefficient of x squared, this way, the coefficient of x squared, the coefficient refers to the number in front of this. When it is positive, you will get a minimum curve or a minimum graph. So here, let's visit our previous question. Here, you realize the coefficient of s squared here is positive. You can see from here, it's positive. So therefore,